Hello grade 11s. Today we're going to be looking at the next part of reduction formulae, co-ratios. So let's just quickly revise what we've done so far with regard to reduction formulae. So we've had the triangles in different quadrants, right? The angle in different quadrants, and then we saw that in quadrant 2, for example, that is like 180 minus theta, that is where the ratio of sine is positive. In quadrant 3, we saw, well, that is where it's 180 plus theta, and that is where tan's ratio is positive. And then lastly, in quadrant 4, we saw that is where cos's ratio is positive. That's 360 degrees minus that reference angle theta there. Okay, so what we're now going to do is, so this is by the default, right? 180 minus, 180 plus, 360 minus. Now we're going to look at the co-ratios. So the co-ratios, simply is you've got that same point in the quadrant, right? So for example, the first quadrant. So, and you would normally make a triangle like that, right? And then that's adjacent. If that's your reference angle, that's your hypotenuse. There's your adjacent, there's your opposite. Okay, or your x and your y and your r. Now what's happening is we're going to draw a triangle differently. We're looking at the co-ratio. In other words, the 90 degrees minus the theta. Okay, so in the first quadrant, we're going to look at what happens with 90 degree minus theta. And in the second quadrant, we're going to look at what's going to happen to 90 degrees plus theta. In the third quadrant, we're going to look at what's going to happen to 270 degrees minus theta. And in the fourth quadrant, we're going to look at what's going to happen to 270 degrees plus theta. Okay, so these are the co-ratios. Okay, co-ratios. What are they? Where do they come from? What are they dangerous? No, they're not. So there's just one extra step actually that's involved in just simplifying these reduction formulae. Okay, so let's go for it. What are they? So let's look at our normal triangle. So say for example, I gave you a point here, the point P here, and the point P is, for example, 3, 4. So 3, 4. So it makes a 3, 4, 5 triangle. So this is equal to 3, that is equal to 4, that is equal to 5, right? With Pythagoras. Good. Okay, so what happens there? Of course, sine theta would be equal to 4 over 5, and cos theta would be equal to 3 over 5, and tan theta would be equal to 4 over 3. Excellent. Now what happens with the co-ratio? So now we're going to look at this part here. So say for example, we've got the same point there, right? The same point P, which is like 3, 4. Okay, that would mean like the x value is 3, right? So that x value is 3. So this distance, in other words, is 3. Hopefully that makes sense. So, and then what we've got is we've got the y value, that is 4. The y value is 4, so that part there is 4. All right. So, and then of course the hypotenuse would be 5. So if I'm looking at sine of 90 degrees minus theta, right? So this is this part here, right? So the 90 degrees minus theta, that angle there. So what's going to happen if that is my reference angle, right? So that would be 90 degrees minus the angle. And so what's going to happen there? So sine then is going to equal to 3 over 5. And cos 90 minus theta in that triangle is going to equal to 4 over 5. And tan 90 minus theta is going to equal to opposite, so 3 over 4. Excellent. Okay, so what happens here? So let's quickly make an observation here. So look at sine 4 over 5, and look at sine there is 3 over 5, cos there is 3 over 5, cos there is 4 over 5. Oh, yet look. So what happens? So the ratio of sine of the normal triangle is the same as the ratio of cos in the 90 degree minus angle, and then the ratio of cos in your default triangle is the same as the sine of that co-function. Okay, so the word we spent a lot of time on this in grade 10, but you know, you never I'm never sure if you're actually listening to me, or you're just shaking your heads, you know. Well, sometimes you don't even shake your heads, you just frown and have that facial expression of just eating, I don't know, something very bad. So let's quickly look at this. So sine is actually, so if you're talking about sine of an angle, it's actually sine of an angle, right? And then what is cos is actually cosine of an angle, right? What's the difference between sine and cosine? They are co-functions of each other, right? So what is a co-function? Well, think about if an angle is 90 degrees, right? So angle is 180 degrees, we call it supplementary. If an angle is forms a 90 degree, if it forms a 90 degree angle, we say it's complementary. So think of that, complementary, CO is in the beginning. So so what happens? What happens in all of these in the triangles? Let's look at this triangle and let's look at that triangle to take that point further. If I look at my adjacent here is 3. In this triangle, my adjacent is 4. In this triangle, my opposite is 4. In this triangle, my opposite is 3. Do you see what happened? Is your adjacent and your opposite swapped. So in each of these, your adjacent and your opposite sides, your x and your y, swapped, right? So they change. The co-function is exactly that. Your opposite and your adjacent, your x and your y, those two swap. What is the big difference between the ratio of sine and cosine? Well, sine is opposite of adjacent, right? Opposite of hypotenuse, sorry, y over r. And what is the ratio of cos? Well, that is equal to adjacent of hypotenuse, x over r. The only difference between them is that the x and y are different, or swapped. So what is a co-function? In simple terms, well, that means your opposite and your adjacent swaps. Okay, but that's quite significant. I mean, it's not, we're not going to treat this lightly, right? Because this will have a major impact on this. And if I give you something like this, if I ask you sine of 90 minus theta, you don't want to draw a triangle the whole time, right? So we need to get a couple of quick steps there. So fear not, if whatever I've just done makes absolutely no sense to you, just hang in there. I'll show you an algebraic approach, just how to solve these very methodically, very step by step. It's not too bad. Okay, so let's look at those co-ratios. So in quadrant 1, there's two questions I think you need to ask yourself. The first question is my function, my original function, right, sine, cos, tan, is it positive or negative in the quadrant specified? Okay, so first question is, so 90 minus theta in all of these, right, is in quadrant 1. Is sine 90 minus theta, is sine positive, is the ratio of sine positive or negative in quadrant 1? Is the ratio of cos positive or negative in quadrant 1? And is the ratio of tan positive or negative in quadrant 1? And in all these cases, everyone is positive in quadrant 1, right? That's the only quadrant where they're all positive. So, well, each of these ratios would be positive, right? Good. So that's your first question. Your second question is it a ratio, right? Is it a co-ratio? Is 90 minus theta a co-ratio, right? 90 minus theta would be there. Yes, it is a co-ratio. Okay, and what happens with a co-ratio? Your adjacent and opposite swaps, right? So in other words, what is the co-ratio of sine? So what's the co-ratio of sine? That would be cosine. What is the co-ratio of cosine? That would be sine, all right? And then for some reason, this is not in the syllabus, but what is the co-ratio of tangent, right? That would be cotangent, right? And what is the co-ratio of cotangent, right? That would be, of course, just the tangent. Okay, so in other words, if it doesn't have a co, you put a co. If it has a co, you take the co away. All right, so that's what a co-ratio means, right? It's the co-ratio of sine is cosine. Sine, cos. What's the co-ratio of cosine? Just sine. So what's the co-ratio of cos? Sine. Hopefully that makes sense. So let's go back to our questions. First question, is my original function, right, the one given to you in that specific quadrant, positive or negative? Second question is it a co-ratio? And if yes, right, then change. So let's do, sorry. So if yes, then change. If the answer is no, then leave the same, right? So that is, leave the same is like what we did in the previous video. So sine 180 minus theta, that's not a co-ratio, right? So you just leave it as, that's just going to be, you know, you just look at the sign, whether it's positive or negative. But a co-function needs to change, a co-ratio needs to change. Okay, so what's the co-ratio of sine? That will be cos. So it will be cos of theta. What is the co-ratio of cos? That would be sine of theta. What's the co-ratio of tan? That will be cot. Okay, let's look at quadrant 2. So quadrant 2, we're going to have the triangle that's like there, right? So that is 90 degrees plus theta there. What's quite interesting, of course, it's obvious, but that angle there would be 90 degrees, but that's not really helpful, I think. So let's go for it. So that will be sine 90 plus by theta, cosine 90 plus by theta, and then tan 90 plus by theta. All right, let's go for it. So first question is my original function positive or negative in this specific quadrant? This is all quadrant 2. Is sine positive in quadrant 2? Yippee yay. Is cos positive in quadrant 2? No, the ratio of cos is negative in quadrant 2, only sine's positive. Is the ratio of tan positive in quadrant 2? No, the ratio of tan is negative in quadrant 2. Second question, is it a co-ratio? What is a co-ratio? It's all the co-ratios would be, let's put it there, it is 90 minus theta, 90 plus theta, 270 minus theta, and 270 degrees plus by theta. All right, so those are all your co-ratios. Good, let's go for it. So these are what's the co-ratio of sine? That would be cosine, cos. What is the co-ratio of cos? That would be sine. What's the co-ratio of tan? That would be cot. All right, in a similar way, in quadrant 3, okay, so that is where it's 270 minus theta. All right, so we are now sitting here somewhere. All right, so there's our 90-degree triangle. Okay, so those are all those co-ratios. So the first question you're going to ask, my original functions, are they positive or negative in this quadrant? Let's go for it. Is sine positive or negative in quadrant 3? Negative. Is cos positive or negative in quadrant 3? Negative. Is the ratio of tan positive or negative in quadrant 3? No, it's positive. Okay, good. Now the second question is, am I dealing with a co-ratio? Yes, 270 minus theta is a co-ratio. So therefore, what is the co-ratio of sine? That would be cos. What is the ratio of cos theta? That would be sine theta. And what is the co-ratio of tan theta? That would be cot theta. Okay, hopefully you're getting the sense of this. So, the idea. So let's consider those in quadrant 4. So 270 plus theta, right? So that is where, that's a 90-degree angle, but 270 plus theta. So you're in that quadrant there, quadrant 4. All right. So what happens in quadrant 4? Who's got a positive ratio? Remember first question, my original function, does it have a positive or negative ratio in that quadrant? So is sine's ratio positive in quadrant 4? I can't hear you. Yes, so it's negative. Cos's ratio, is it positive or negative in quadrant 4? Positive. And tan's ratio, is it positive or negative in quadrant 4? Come. Yeah, so it's negative. Yes. So is 270 plus theta, is that a co-ratio? Yeah, it is. So therefore, what will sine theta change to? Well done, cos theta. Yes. So, and what will cos theta change to in a co-ratio? Yes, well done, you're getting it. And what will tan theta change to in a co-ratio? Yes, cot theta. So it's minus cot theta. So that is the basic, you know, just what's you know, concept of co-ratios. So it is the co-ratio, in other words, is when you draw the triangle in such a way that your x and your y swaps around, right? Your opposite and adjacent swaps around. In other words, and what is the difference between sine and cosine? Sine and cos, opposite over hypotenuse versus adjacent over hypotenuse. The opposite and adjacent swaps around. What's the difference between tan and cot? opposite over adjacent and adjacent over opposite. What am I saying? Tan is opposite of adjacent, and then the other one is adjacent over opposite. Yes, so those are also co-functions. But it even gets better. So, and just the last part here. What would be the co-function of cosec theta? Yeah, what's the co-function of cosec theta? That will be sec theta. And what is the co-ratio of sec theta? That will be cosec theta. Okay, so that's also quite cool, I think, even with those reciprocal functions. And just why that is, of course, cosec is the reciprocal of sine, and sine is opposite of hypotenuse, or y over r. So this is now, oh goodness gracious, y over r becomes r over y. There we go. So r over y, and what will sec theta be? So what is the reciprocal of sec theta? What is the difference? What's the co-ratio? Okay, so remember the opposite and hypotenuse. My goodness, the opposite and adjacent swaps. So therefore the y will become an x, r over x. Okay, and that is sec theta. Right, and sec theta is r over x, same story, so that will become r over y, and that is cosec theta. Okay, again, so it does it have a co? Yes, take it away then. That's what the co-ratio do. Or if it doesn't have a co, you give it a go. Co. All right. Okay, so let's work through two examples quickly. So just for you to get a better sense of what's going on. So the first part is, so if I ask you to simplify 2 cos 90 minus x minus sine 360 minus x over 2 sine 90 minus x minus cos 180 minus x. And I know I shouldn't say this, but I just for my own health and safety, and for yours, let's just quickly just make sure that we're all on board. Yeah. You cannot divide those angles out. You cannot divide those sines out or coses out. You can't divide those x's out. So if you thought of doing any of those, please don't. All right? I don't know. Get a elastic, put it around your arm and zap you when you do that, or when you're thinking of doing it. Please, you can't do that. Okay? So remember, this is not distributive property. You can't just multiply the cos in. It's cos of an angle. It's 2 times the cosine function of that angle, minus sine of the sine of that angle there, 360 minus x. All right, do you follow? So these are all, that's one thing, the trig function and its angle. I know I probably don't need to tell you that. Hopefully I'm just making sure. All right, let's go for it. So again, what's better than doing one question? Let's do 4 questions. Yes. So what we've got here is we've got cos 90 minus x. Okay, so let's follow our structure here. My first question is the ratio of my function positive or negative in this specific quadrant? Okay, so we're going to ask, is cos 90 minus x? Where's 90 minus x? Okay, where's 90 minus x? That would be in the first quadrant, right? So it's there. So is 90 minus x, is cos positive there? Well, it's positive, yeah. Everyone's positive in quadrant 1, right? Is it a co-ratio? Yes, it is a co-ratio. My triangle is on the wrong side. It's bordering on the horizontal line, right? My x and y will swap. Okay. What will happen then? So cos 90 minus x. What is the co-ratio of cos? That would be, yeah, that will be. So it's positive sine x. Okay, you don't need to put the plus there, right? But it's a positive sine x. I'm just doing it for illustrative purposes. Okay, the next one. So then we've got a negative 1 times by sine. And if you want to put there a minus 1, go for it. And then we've got sine of 360 minus x. So again, first question. Where's 360 minus x? It's there. All right, let's make that one this purpley color. Is sine, what quadrant is that? 360 minus x is quadrant 4. Who's positive there? The cos ratio is positive, right? So the ratio of cos, is positive. So is sine positive or negative in that quadrant there? Sine is negative, right? And is it a co-function? 360 minus x? No, that's by default. By default, remember all those angles that's 180 minus the angle, 180 plus the angle, 270 degrees minus the angle. So if it makes that bow tie. So then you don't need to change it, right? It's not a co-ratio. Good. So because your opposite and opposite and adjacent doesn't swap. Okay. So therefore, do I need to change sine to cos? No, you don't. It's not a co-ratio. So that will just become sine x minus sine x. Okay. Then what we've got is on the denominator there, we've got sine 90 degrees minus x. Okay, 90 degrees minus x again. Which quadrant am I talking about here? 90 minus x is quadrant 1. Is sine positive or negative in quadrant 1? It's positive there. Is it a co-ratio? Is it a co-ratio? Yes, my triangle is a bit skiff. So it's, you know, the opposite and adjacent will swap. So therefore, what happens? That will then become positive cos x. Right. And then lastly, we've got minus cos 180 plus x. Okay, so minus 1 times by cos 180 plus by x. Where's 180 plus by x? It's just like there. It's a normal triangle. All right, let's make this one this beautiful bluish color. So what's going to happen there? 180 plus by x, that's quadrant 3. Is cos positive in quadrant 3? No, it's very negative there because the ratio of tan is positive there, right? And is cos now going to change to sine? Is it the co-function? No, it's part of the normal bow tie. All right, so that will just stay minus cos x, but it's minus cos x. Okay, and now it's just a bit of simplification. All right, it's nothing. So this is the most crucial part, right? The rest will get better as the more we do, more identities we're going to do. Okay, so let's go for it. So we've got 2 times by positive sine x is 2 sine x. Then we've got minus 1 times by minus sine x is plus sine x. And then on the bottom, the denominator there, we've got 2 times by positive cos x is equal to 2 cos x. And minus 1 times minus cos x is plus cos x. Okay, how do I simplify that? 2 sine x plus sine x, what is that equal to? I don't know, 2 marshmallows plus another marshmallow is 3 marshmallows, yes. And yeah, so 3 sine x. And what is on the denominator? 2 cos x plus cos x is equal to 3 cos x. Right? 2 donkeys plus 1 donkey is 3 donkeys. So we've got 3 sine x over 3 cos x. Okay? Do we have one term now? Absolutely yes. Now you can divide those 3. Do not tell me they cancel. They do not cancel. They divide. I will track you down. I can sense these things. Some of you thought cancelling. They don't. Don't use the C word. It's bad. Slap you on your hand if you do that. So we've got sine x over cos x. Now this is totally cool. We want to write our answers in terms of sine x over cos x, but just that is also the same as saying tan x. Okay, so they are all the same. Okay, so this is an example of how this plays out. I'm going to do one more with you. Okay, so example 2 here. So let's go through it. So we're being very methodical, step by step. All right. Don't throw a tantrum. Little emotion here, right? So just treat it. These are 4 questions built into one. Okay, it's one of those all type gadget things. Okay, so let's go over the first part. So we've got cos square 90 minus x. So what's my first question I need to ask? Come, talk to me. What's my first question I need to ask? What's the first question? Yes, well done. So cos square 90 minus x is... Okay, so that's the same as whatever that answer is square, right? 90 minus x is in which quadrant? It's in the first quadrant, right? It's in the first quadrant, 90 minus x. Is cos positive there? Is my original function positive or negative there? It's positive there, everyone's positive. Is it a co-ratio? Yes, cos will change to sine. So that will be the co-ratio of cos x will be sine x. All right. Next part, we've got sine square 90 plus by x. So, okay, same story. So let's make this one that beautiful bluish color. So, although I'm probably going to get some feedback around that. It's not blue, it's some, I don't know. So here we go. So sine square 90 plus by x is equal to, it's in the second quadrant. So again, so what we've got there is that's a square there. So is sine positive in that quadrant too? Yes, it is positive. Is it a co-function? Yes, 90 plus by x is a co-ratio. So therefore sine x will change to cos x. And on the bottom, what do we have? We've got tan 180 plus by x. So let's make this the purplish color. There we go. And tan 180 plus by x is in where would we locate that? It's in the third quadrant. Is tan positive in the third quadrant? Yeah, but yes. Okay. And is it a co-ratio? No, it's not a co-ratio. It's part of that nice bow tie effect. So that would just stay tan x, right? And then lastly, we've got sine. Oh no, that's not a plus. I'm so sorry. That's a times. And what are we going to do that? So we're going to make it this part, whatever the color that is. So what we've got is we've got sine 90 plus by x. 90 plus by x again is in the second quadrant. It's a co-ratio there. Is sine positive in the second ratio? Yes, it's positive. But do I need to change sign? Yes, I need to, because it's a co-ratio, so that will become cos x. Okay, so this is the big part. I mean, that's where you get the majority of the marks for. That's what we're trying to see if you can do. The rest is just nice. We're trying to be clever and put some, I don't know, looks horrendous in the beginning and then it simplifies quite nicely. So anyway, so here we go. So what we've got is on the numerator there, we've got sine square x, right? Sine x times sine x is sine square x. And then we've got cos square x. Cos x times by cos x is cos square x. Good. And then on the denominator, we've got tan x. Tan x is sine x over cos x. Right? And then we've got times by cos x. So what is that equal to then? So on the numerator, what is sine square x plus cos square x? That is again equal to, remember that's one of the two identities. The one identity is tan x is sine x over cos x. The other identity is sine square x plus cos square x is equal to uno. Uno. So yes, it's equal to 1. And then what we've got is we've got, so cos x over 1 times sine x over cos x. So the cos x is divide. So what do we have left? So it's 1 over sine x. And that is totally cool to leave it as 1 over sine x. Also just 1 over sine x is also equal to cosec x. That is also cool. So any of those forms. So but yeah, but this is the big part. So even if you can't 100% simplify to 1 over sine x, I don't mind, but you just need to, it must look something like, it must look like that for now. Okay, the rest will get easier once we've done identities. Okay guys, so now you're going to practice a bit. Well done folks, you've done so well. I am so proud of you. You should see my smile. And yeah, well done. Just keep on working harder. Hashtag hard work pays off. Wash your hands. And yeah, well done. I'm so proud of you. Okay, that's enough now.